So just for 2 or 3 slides, very small overview. So what is big data? So after that, we are directly entering into Hadoop and HDFS, a small base on MapReduce. Then the two excellent frameworks which plays a vital role in the top of Hadoop. The frameworks named as Hive and HBase. So the overview of Hive as well as HBase. It's a small agenda for this 3-hour session. So big data overview, Hadoop, HDFS, and the MapReduce, the two core components, Hive and HBase, two excellent database components. Yeah, just a small overview. What is big data? So what is big data? All are very much familiar about the buzzword big data. So a picture, normally a picture may worth 1,000 words. Here there is a picture, a person holding a stone. It's a small stone or large stone. Beyond this capability, the stone which will be called as large stone. So same thing, big data is amount of data just beyond technology's capability to store, manage, process efficiently. So for example, if you are having a PC, the PC of Pentium 4, a Pentium 4 machine. So if you are having a data of 1 GB, the machine, it's not capable of processing 1 GB of data. Then that data is called as big data for that P4 machine. So big data is just amount of data just beyond technology's capability to store, manage, and process. So what is big data? So similar way, it's amount of data, but the data in the form of either structured or unstructured way. The data are stored in either structured or unstructured way. So data has extra large volume, comes from variety of sources, variety of formats, and with a great velocity. So how to manage it? Already data is in structured as well as unstructured way. Here the data volume was huge, which comes from variety of sources and in variety of formats. There are several set of raw formats, variety of formats, and data also comes from in a rapid manner. So how to manage this amount of data? It's a very typical thing. Very smallest example was social media. So each and every day there are numerous number of sharing, numerous number of tweets, numerous number of messages. So how to manage this amount of data? How to extract smart data from this amount of big data? Actually, these data are not waste. This data also provides several set of intelligence. So how to manage, how to process this amount of data? It's a major theme of big data analytics. So starts from a base. So data. Yeah, data are classified into 3 basic categories. The first one, which is termed as structured data. So structured data, our normal relational database. So your data are properly managed in a table. So each and every columns are properly defined with the data type as well as size. So everything was properly defined. That column size as well as column type. So for managing structured data with the help of relational database management system, it's very, very easy. The second thing, semi-structured data. So first thing, structure. So managing structured data is very easy. The second thing, which is called a semi-structure. Then in that situation, a little bit typical thing was happen. So how to manage semi-structured data? So the first thing, very easiest thing, comma separated value, CSV. So each and every column data is separated by comma. Each and every data is separated by comma. So A is the first column data, B is the second column data, C is the third column data. So everything is separated by comma. So the second one, XML, extensible markup language, a tag based, user-defined tag based one. Currently, each and every organization, they are using the excellent format. Each and every industry, 99.9% of industry, they are managing their data via JSON, JavaScript object notation. JavaScript object notation. It's excellent semi-structured database for managing your data. Now, the last one, not only SQL database. So semi-structured data, which is managed via comma separated value, XML extensible markup language, the excellent DB, which is named as JSON, and not only SQL database, no SQL database. So structure, the second thing which is called as semi-structure. Now you are entering into the third part, unstructured. So if data are in unstructured format, in that situation, you can manage this data in a very, very hard. So some of the unstructured data, machine generated data, something like satellite images, scientific data, photographs, video, radar data, sonar data, human generated data, something called as WAD file, PDF file, text file. Yeah, this is the biggest issue of big data, social media messages. Each and every day there are numerous number of forwarded messages, numerous number of text content, numerous number of tweets. So how to manage social media content? How to extract smart data from this social media content? It's a thing. So then mobile data, so normal SMS, MMS, etc., etc. Website contents like blogs, Instagram. So all these data are not having a proper structure. So how to store, how to create an index for these data. So always index is essential. If a data or if a file or if a document or if a graph which has a proper index, then only it's possible for retrieving the same. Think about your home kitchen. So if you are arranging item in a proper place, then if you are having a proper index, then only you can fetch item easily. If you are thinking about your college library, so if you are searching a book, each and every book is indexed properly, then only it's easy for searching a book. Similar way, now you are pushing data, just pushing each and every data, each and every social media data. Then how to retrieve? It's like a dump. It's like a dustbin. So how to fetch useful data from that information? So it's very, very typical. So the proper indexing, proper metadata is essential for a big data. So it's a theme of today's session for big data analytics. Yeah. So storage, we start from kilobyte, megabyte, and gigabyte. These three are in blue color. So for managing this data was very, very easy. Terabyte and petabyte, it's fine. Normal server is enough. If the data was exabyte, zettabyte, yottabyte, in that situation, it needs a distributed file system for managing data. If the data size was larger, then in that situation, for managing this data, you can need expensive hardware. So purchasing expensive hardware, it's very tough. So in that situation, you can connect the commodity hardware to create a distributed file system for managing these kind of environment. So exabyte, zettabyte, and yottabyte of data, which need a distributed file system for managing the data. Yeah. Even in 60 seconds, this amount of Facebook share, this amount of emails, yeah, 430,000 tweets in a 60 seconds. YouTube, then each and every social media, Netflix, WhatsApp, etc., etc. So in a 60 seconds, this amount of huge data. So how to manage large data, how to process large data, how to store large data. This is very, very typical thing. So even it's because of social media. So nowadays the social media data are something like iceberg. So even Titanic can't manage iceberg. So how to manage these things? So save big data. No more time. So now we are processing. We are entering into the stage of processing big data or storing big data. So just for a small example, just for a very small example for big data. So a flight which traveled from Bangalore to US, San Francisco. The travel distance was 8,699 miles. So the total travel distance was 8,699 miles. Then, so travel time was 22 hours. So even a single journey from Bangalore to San Francisco, the data generated was 1,100 terabytes. That is 1,100 into 1,024 GB. So even a single journey, even a single flight journey, sorry, even a single flight journey would generate 1,100 terabytes. In addition to that, there are several set of data recorded in airports, etc., etc. So how to manage single journey which will generate 1,100 terabytes? So Yeah, just for a small overview, big data initially starts from 3V, now in 6V. So 3V technology, so volume, velocity, as well as variety. Volume in the sense a large amount of data just for a pictorial representation. Yeah, afternoon session it's very tough to listen. So just for refreshing your eyes, small pictorial representation. Yeah, volume. So it's large volume. So a large volume of data. Then velocity, a data set comes from a rapid manner. Variety, ice cream in variety of flavors, something like that. So data set comes from variety of formats. So volume, velocity, variety. Additionally, the fourth we added. Now fifth and sixth we also added. So fourth V, which is called as veracity, that is the truthfulness of data. So verify whether the data is correct or not. Verify whether the data is correct or not. So the veracity is very, very important. So one fine day, yeah, I'm uploading a data to a cloud. So something a wrong definition of computer or wrong definition of cloud to a database. So normally data was uploaded. Even a search engine also display the data. How to verify the truthfulness? How to verify the veracity? So it's very, very important. So first one volume, second one velocity, variety, the fourth one veracity, the fifth V, which is called as value of data, the business value of the data. In addition to that, the variability of data, the way in which the big data can be used and formatted. So there are 6V. Currently, the 6V technology, which is dominating big data, the volume, variety, velocity, veracity, value, and variability. This is a 6V technology. Yeah. In olden days, in the 1980, it's a 32 KB memory size. Currently, the memory size was very, very tiny. Even memory size was reduced, but we are using very large amount of data. Even 32 GB or 128 GB storage is not enough for a user mobile phone. So we need a larger memory. So how to manage? So small analogy for big data processing. So yeah, even as sugarcane industry, small analogy for sugarcane industry. So yeah, normally you are harvesting, yes. Then extract the thing, evaporate, distill, as well as boil. At last, you will get a sugar. So it's a process which happens in sugar factory. Similar way, an enterprise of big data factory, a large data which is harvested, you can acquire the data via the excellent platform which is termed as HDFS, Hadoop distributed file system. Otherwise, not only SQL database, a normal relational database management system. So you can process, you can acquire, you can gather the data via HDFS, not only SQL database or RDBMS process. So HDFS data which is processed or extracted via MapReduce algorithm. So Hadoop, which comprising of two core components, one which will be termed as HDFS, the second one which is termed as MapReduce. So here HDFS and MapReduce we choose to extract the information. No SQL database which connected via any big data connectors, MongoDB or Cassandra or even Hive or HBase, something like that. So RDBMS normal ODBC connect.